Hi everyone, my name is Andrea Azzori and I'm a PhD student at University of Cagliari. In this presentation, I will be briefly presenting our work on demographic fairness of exposure in forensic face rankings, co-authored with Gianni Fenu and Mirko Marras. In a face recognition identification task, the system receives as input a photo of an user. The system task is to infer the identity of the user, searching for the most plausible match in the gallery of known identities. A face identification task in the form of a ranking system takes as input a query photo, the probe, a set of galleries of known users, the items, and a similarity criterion. The ranking system outputs the set of identities sorted, or better ranked, congruently with the similarity criterion and the given probe. In rankings, the exposure metric is used to calculate how well a given gallery, representing a user, is predisposed to relevant positions. The higher the exposure, the more likely the gallery is to appear in the highest, and therefore most relevant, positions in the rankings. Therefore, the aim of our work is to analyze to what extent face ranking systems emphasize group discrimination in terms of exposure. To contribute to explore this perspective, we perform an analysis on exposure fairness across probes' demographic groups, and an analysis of overall disparate exposure of demographic groups. Our work was based on the DIVE-FACE dataset, balanced with respect to ethnicities, Asian, Black and Caucasian individuals, and gender, for a total of 6 demographic groups. This dataset was divided into 2 balanced parts. 70% was used to train our models, and the remaining 30% was used in the testing phase. Before being used, the images in the dataset underwent a series of preprocessing steps. First of all, we performed a face detection and alignment step on each photo. Then, we cropped out the face-only area in order to perform a resizing step to normalize the shape of every image. To extract latent representations from each image, we built and trained a range of face encoders based on state-of-the-art convolutional neural networks backbones. Only during training, each backbone was plugged into a classification head. For each user, we randomly sampled 10 photos belonging to him or her. After that, removing the classification head from the models, we used their trained backbone to extract the 512 sized latent representations of the chosen photos. Of the 10 representations, 3 were sampled to be used as probes or queries in the ranking system, while the other 7 were used to construct the user gallery. Finally, once the gallery was constructed, its representations were averaged to construct a unique one representing the user. To obtain the data for our experiments, we then followed the following procedure. For each model, considering one demographic group at a time, namely Asian male, Asian women, Black male, Black women, Caucasian male, and Caucasian women, we obtain, distinctly for each identity, the similarities between each probe belonging to the identity and the galleries of all the users. After that, we ranked the galleries and the identities they belong to accordingly to the similarity with the probe, in descending order. In our work, we posed our focus on 2 main research questions. The first one aimed to analyze exposure variations among groups accordingly to probe's demographic group, while the second one aimed to inspect the overall exposure of each demographic group, in order to better understand which ones are most likely to incorrectly appear in the top positions of the rankings. In a first analysis, for each probes group, we computed the average exposure of each demographic group across rankings and models. As expected, the demographic group with the highest exposure correspond to the probes 1. Going beyond this case, probes of Asian men led to disparate exposure for Caucasian men, same gender, and Asian women, same ethnicity, compared to the other groups. Similarly, the rankings emerging from Asian women's probes disproportionately represent Caucasian women, same gender, and Asian males, same ethnicity. Probes from Black men make Caucasian men and Asian men more prominent. In both cases, the gender seemed to be the main causing factor. Black women probes, conversely, led to higher than more equal representation across certain groups beyond that of the probe. For instance, Asian women and Caucasian females and males are unfairly more at risk of incorrectly appear in the top of the rankings. Caucasian probes make same ethnicity counterparts more prominent, along with Asians of the same gender. In a second analysis, we investigated whether the observed disparate exposure across demographic groups is even more evident if we consider the position in which a certain possible suspect appears. Since our results were consistent across models, the figure shows the exposure distribution of groups across rankings, averaged among models. Asian women often tended to be fairly represented in the top positions, immediately followed by Caucasian men, Caucasian women, and Asian men. Moving to conclusions, our results highlighted that dark-skinned individuals, especially women, have lower exposure under probes belonging to other demographic groups, especially female ones. Even more noticeably, dark-skinned female probes produce the less disparate results compared to all the other groups. In addition to this, Asian and Caucasians are overexposed in the rankings, while women appear to be the most likely to hold prominent positions. In the next steps, we plan to investigate whether, and possibly to what extent, other factors like pose, lighting, and expression influence the considered forensic face rankings. We also plan to devise potential countermeasures regarding the disparities in treatment we uncovered through our studies. I really hope you enjoyed this presentation. Thanks for your attention and see you online on June 8th at the 13th Italian Information Retrieval Workshop.